Hey y'all, let's cover lesson 29, and this is ratios and rates. So a ratio, okay, is a quotient. Now remember, quotient means divide. So a ratio means we're going to divide something it's a quotient of two numeric quantities. So two numbers, two numeric quantities with no units or the same unit. So what they're saying is if you have 3x and you have 6x, you can take a quotient of those two numbers as long as they have the same x, like one's an x and one's a y, you can't do it. But if they're both x's, you can do it. The other thing is if they have nothing other than the numbers themselves, or inches or feet, or however you want to think of it that way. So there's a number of ways to express ratios. We're gonna use three of them. The first is fractions. So 3 divided by 4 is the same thing as 3 to 4. It's a ratio as 3 is to 4. Okay. So express each of the following ratios as a fraction reduced to lowest terms. 36 to 24, that's the same as 36 divided by 24. So I would do my trees. 24, 36, I think of as 6 and 6, 3 and 2, 3 and 2, and then 24 as 4 and 6, 2 and 2, 3 and 2. All right, so between these, they have two 2's and a 3. So two 2's is 2 times 2 is 4 times 3 is 12. So I can divide both of these by 12 and reduce it to 3 over 2. So therefore, it's a ratio of 3 to 2. All right, 0.12, so 0.12 to 0.18. Well, I can start by just getting rid of the decimals because I don't want to deal with that. It just doesn't make sense to me. So I'm going to multiply both of these by 100. And that's the same thing as multiplying by 1. So that's 12 divided by 18. And now I can come up and do my reducing. 4 and 3, 2 and 2, 6 and 3, 2 and 3. So a 2 and a 3 from each of these can go away, which is 6. So divide both by 6, and we get 2/3. Okay. For the rectangle below, express the ratio of length to width as a fraction reduced to lowest terms. And they want length to width. And that's how you would read that. Length to width, length to width. The division symbol takes the place of the 2 because this is going to be a quotient. So my length is what? Well, it depends on what you want to call it. Some people think of this as the width. Some people think of this as the width. I always think of the one that's across as the width and the other one is length. Right now, it really doesn't matter. So let's just say 3 1/4 is the length and 2 1/2 is the width. First thing we need to do is go around the world for each of these. 4 times 3 plus 1, so 12 plus 1 is 13 over 4, divided by 2 times 2 is 4, plus 1 is 5 over 2. All right. So this is the same thing as 13 over 4 divided by 5 over 2. Keep, switch, flip. 13 over 4 stays. We keep that one. Switch from division to multiplication, and then flip from 5/2 to 2/5. All right, can we reduce? Yes, the 2 and the 4 reduced by 2. This becomes a 1, this becomes a 2. Now we're done. 3 times 1 is 13. 2 times 5 is 10. Okay, so that is our ratio. One of the most famous ratios is the golden ratio, which is a ratio of length to width of rectangles. and ancient Greek geometers believed rectangles with this specific ratio were most pleasing to the eye. Architects and artists today still use the golden ratio in design. You'll see that a lot. The golden ratio is approximately equal to this number, but it continues on and on forever. So we talked about ratios. Now let's talk about a rate. A rate is a comparison of two quantities, with different units, What is the important difference between the ratio and a rate? What is the word we often see when dealing with rates, and what does it mean? So a ratio means they're the same. A rate means they're different units. And the ratio, they have to be the same units. So with rates, we're dealing with a per. The word per is what we see. It means for everyone. Okay, so here's examples. 50 miles per hour. So that's per 1 hour. Okay, that means 50 miles per, or for every 1 hour. And that's the way that's thought of. Okay. An automobile travels 224 miles on 12 gallons of gasoline. Express the ratio of distance traveled to gas consumption as a fraction reduced to lowest terms, and then write a short sentence explaining the physical significance of your solution. Include units in your description. So travels 224 miles on 12 gallons of gasoline. So that's distance divided by gas, which would be 224 miles divided by 12 gallons. All right. All we need to do here is to reduce. They're both reducible by 4. I know that by looking at them. So let's try that. Divide both by 4. 224 divided by 4 is going to give us 56. And that's miles. And 12 divided by 4 is 3 gallons. So for 56 miles, we can go 3 gallons. So that means you can travel 56 miles on 3 gallons of gasoline or of gas. Okay. A unit rate. So this is just a rate. This is a rate. Notice neither one of these numbers are 1. It's 56 miles to 3 gallons. That is a rate. A unit rate is a rate whose denominator is 1. Okay, so that in this case would be, this one would need to be a 1. A unit rate is typically expressed as a whole number or a decimal. Okay, here's an example. Well, I can go up here for this one. I want to do the example first. For 56 miles to 3 gallons, how do I make a rate become a unit rate? I just divide. them. 56 divided by 3 is 18.67. Granted, I'm going to go ahead and just round this, but this is just an example to show you how to turn this into a unit rate. You just divide, and I'm going to round this to the 10th place to make this 18.7. So that would make this become a unit rate. It can become a unit rate, if I can do this, by dividing. And I just want to show you what that would look like. So that would be 18.7 miles per gallon. So it would be over 1. Okay. In this case, Herman drives 120 miles in 4 hours. So we've got distance over time. 120 miles divided by 4 hours. I'm going to reduce that. 120 divided by 4 is 30 miles over 1 hour. So this goes to make sense that it's 30 miles, and then here's the word, per hour. That's when it becomes a unit rate, is when there's a 1 in the denominator. All right, so it's 30 miles per hour. Aditya works 8.5 hours and receives $95 for his efforts. What is his hourly salary rate? Okay, well, his salary rate is going to be dollars per hour. So it's money per hour, $95. And he gets $95 if he works 8.5 hours. So how much does he get if he only works 1 hour, which is what a unit rate is? So our answer is going to have a 1 hour in the denominator for it to be a unit rate. In order to get that, we have to take that 95 and divide it by 8.5. So he gets $11 and, well, would we say 17 or 18? We would say 18 because we need to round. And you always round to the hundredths place for money. So $11.18 per hour is his hourly rate. So $11.18 per hour is his salary rate. Is his salary rate. All right. One automobile travels 422 miles on 15 gallons of gasoline. A second automobile travels 354 miles on 13 gallons of gasoline. Which automobile gets the better gas mileage? Well, if we put distance over gallons, that's going to be 422 miles over 15 gallons. The other one is 354 miles to 13 gallons. We can't compare them until we get them both at their unit rates. So we have to divide both of them. So 422 divided by 15 is 28.13. And that 3 continues. And that's miles per 1 gallon. The other one, 354 divided by 13, is 27.2 miles per gallon. And now we can compare them because they're both at their unit rates. G. Which automobile gets the better gas? So they're labeled as, well, the first one. This one gets better gas mileage. Okay. Because it gets 28.13 miles per the gallon as opposed to the 27.2. All right. Oh, that's it for 29. I'll see you on 30. Let me know what questions you have.